So now we're going to go through some examples of implicit differentiating just to help get practice on these. So here we have a circle centered at the origin, radius of 5, and we want to find dy dx at this specific point. So again, we're making note of the fact that this is with respect to x. So when I start taking my derivatives, derivative of x squared is 2x. I do not need to use chain rule on it, plus derivative of y squared, which is 2y, but I need the chain rule, so times dy dx, which I don't know yet, and then derivative of 25 is 0. And then if I isolate dy dx, I get that that's going to equal negative x over y. So derivative with respect to x at our point radical 20, radical 5 is going to be negative radical 20 over radical 5, which will simplify to be negative 2. We can also go with more variables. So here, three-dimensional, x plus y plus z equals 10x. If we were to find dy dx, again, looking at it with respect to x, that means anything that is not an x is going to require the chain rule. So derivative of x is 1, don't need the chain rule, plus the derivative of y, which is also 1, but I need the chain rule, dy dx, plus derivative of z would be 1, but I would need the chain rule, so dz dx. And then derivative of 10x would be 10, and I wouldn't need the chain rule. Again, because all of these are with respect to x. It's okay that there's a dz dx in there. We don't know what it is, but we're not being asked for dz dx. We want to figure out dy dx. So if I now isolate dy dx, I would subtract the 1 and then subtract dz dx. And this is dy dx. I know it looks a little strange that we have a derivative that depends upon a different derivative, but in terms of real-life applications, that's pretty common, and it's not really an issue for us. So that's okay that we still have dz dx in there. Let's say, though, I wanted to find dx dz. So this time, we're looking at it with respect to z. So anything that is not a z is going to require the chain rule. So derivative of x is 1, but I need the chain rule, dx dz, plus the derivative of y, which is 1, but I need the chain rule, so dy dz, plus the derivative of z, which is 1, but that's with respect to z, so I don't need the chain rule. And then the derivative of 10x is 10, but I need the chain rule, dx dz. Well, now I have dx dz, which I want to know what that is. That's on both sides. I'm just going to move all my dx dz's to one side by subtracting this 1 dx dz. And so that's going to give me dy dz plus 1 equals 9 dx dz. Then divide everything by 9, and so dy dz plus 1, all divided by 9, is dx dz. If we go a little bit more complicated functions, that we can do this with other functions and more, and our other derivative rules involved in it. So here, again, with respect to x, so derivative of 2y is 2, but I need the chain rule, so times dy dx. Derivative of x squared is 2x, do not need the chain rule on it, plus the derivative of sine y, which is cosine y, but I need the chain rule, so dy dx. Again, I have dy dx's on both sides. I'm going to subtract this cosine y dy dx from both sides, so that I have 2 dy dx minus cosine y dy dx equals 2x. I can then factor out a dy dx by doing derivative, or not derivative, by doing distributive property. So 2 minus cosine y. equals 2x. And then divide both sides by 2 minus cosine y, and I get dy dx equals 2x over 2 minus cosine y. I can then even extend this to finding tangents and normals. Now, if you notice by here where we're asking to find a tangent and normal for an ellipse, we're not being told what this is a derivative with respect to. However, we are graphing in the xy plane, so in our kind of standard coordinate plane. So this is implying that we need dy dx. So it's going to be still with respect to x. So when I start taking derivatives, well, 2x, don't need the chain rule, minus, and then I have x times y, which is going to need the product rule. So first times derivative of y, which is 1, but I need the chain rule on that, because this is with respect to x, plus second times derivative of first, and I don't need the chain rule on that. Then going to the derivative of y squared, which is 2y. Then I need the chain rule. And then derivative of 7 is 0. And then kind of distribute my subtraction here. So 2x minus x dy dx. Oops. Minus y plus 2y dy dx equals 0. Then moving the 2x and the minus y to the other side, pulling out dy dx, and isolating it, I get that dy dx equals y minus 2x over 2y minus x. Then we're being asked to write the equation of a tangent and a normal. Well, those are both lines. To write the equation of a line, I need the slope of the tangent, and I need a point. We already know the point, so I need the slope of my tangent. So dy dx, when we're using the point -1, 2, when I plug that in, it's going to give me 4/5. So my tangent equation will be y minus 2 equals 4/5 of x plus 1. And then for the normal, it's going to be y minus 2, and then I need opposite reciprocal slope of x plus 1. And here are my tangent and normal equations. The last video for this is going to go over how we find second derivatives implicitly.